Hello everyone, today we're going to be doing some Line 75 C++ Leetcode, and today we are focusing on climbing stairs. Now, before we get started, let's just make sure we break down the question, ask yourselves the questions, what the input's going to be, what data structure slash algorithm slash technique we need to use, what to do with the data, and then what our output is going to be. So now, you are climbing a staircase. It takes n steps to reach the top. Each time you climb 1 or 2 steps, in how many distinct ways can you climb to the top? So we are given number of stairs, which is our integer. So, and then we need to return exactly how many distinct ways you can climb to the top. So it's like if you have 2 steps, how many ways? So we would have, there are 2 ways to climb to the top. 1 step, 2 step. Then we have 3. There are 3 ways to climb to the top. 1 plus 1 plus 1, 1 plus 2, and then 2 plus 1. And it's also going to vary between the constraints of 145. Okay, interesting. Okay. So, to be able to start, what we are going to be doing with our solution, we're going to be going off of dynamic programming, where it's just like, instead of eating the whole elephant, you're taking bits and pieces of it, so that way you can expand upon the relationships depending on your variables. So, so this is what we're going to do with the data. Let me just... Okay, so 1, we need to do, we need to have the edge case of when n is 1. We're going to initialize an array called dp. In fact, I'm just going to put our initialization up here. We're going to initialize an array, which would be a vector in this case, called dp. And we will need to have the edge case of when n is equal to 1. We're going to return 1. We're going to set our following array of 1 equal to 1 and array 2 equal to 2. So these steps 2 and 3 are going to be our next initialization, and then from step 3 onward, we will set our array of I is going to be equal to the following solution of I minus 1 plus p of I minus 2, with the reason being that we need to fill up the following array as we reach to the ith step, either from the ith step or from the second step already started. So let's just say, for example, we have dp of 3, or dp of 4 in particular. This is how we will actually get our p of 4 minus 1 plus dp of 4 minus 2. It's going to be equal to dp of 3 plus dp of 2. We technically have 5 different solutions of steps accordingly. So we would have our following ways to climb the stairs. since we already are doing one step each, then we do 1, 2 steps, and then 2 step to 1, because we can climb from 1 or 2 steps accordingly. And we have to take into mind of having 1 and then having 2 accordingly. And finally, we're going to be outputting. Unique ways to climb stairs of dpn. Alright, now just to kick things off, we're going to first initialize our vector of int dp. I'm going to call this n plus 1 because we're climbing up 1 stair at least. And if n is equal to 1, then we return 1. And then we're going to set dp of 1, since we're climbing 1 or 2 stairs occasionally. dp of 2 is going to be equal to 2. Since we've already have deciphered it, there is 2 unique ways, and then 1 unique way as well. Then we're going to expand upon the relationship starting from 3 onward. Int I is going to be equal to 3, and then I is going to be less than n, because n can be arbitrary, and then I plus plus altogether. And then we're going to have a formula. It's going to be equal to dp of after the first step, so it will be I minus 1 plus dp, since it's more than 3, I minus 2 is going to be 3 or more for our for loop. And then finally we're going to be returning our dp of n, so that we can get our unique set of elements, unique ways of climbing the stairs. Make sure everything is already correct. There we go. Alright, and here we are. So to just give a whole breakdown of our space and runtime complexity, so given the fact we're using dynamic programming and we are scanning throughout the different possibilities of the number of steps, or time complexity, starting off with that, is going to be O of n, where n is referring to the number of steps in constant time. And then for the space complexity, it's going to be O of n, as we're using an array to keep track of all of the following steps we have visited. Alright, and so this was Climbing Stairs. Thanks again for taking time to watch this. If you enjoyed it, feel free to like and subscribe. If you have any questions, feel free to put them in the comments section. And as always, take care. Cheers.